You work for a consumer agency and want to estimate the population mean cost of replacing a car's transmission. Assume the population standard deviation is $425. You randomly select 40 transmission replacement costs and find the mean to be $2,650. Construct a 95% confidence interval for the population mean repair cost, and then interpret the results. So n is equal to 40, x bar is 2,650, sigma is 425, and c is 0.95. So if we use the z-interval command on the calculator, we find the confidence interval to be 2,518.30 to 2,781.70. And this means, with 95% confidence, we can say that the true population mean repair cost is between $2,518.30 and $2,781.70. On Part B, all of our information is staying the same, except for our sample size is increasing to 70. So we use the z-interval command, and this is our confidence interval. So with 95% confidence, we can say that the true population mean repair cost is between $2,550.40 and $2,749.60. On Part C, all of the information is staying the same, except for the sample size is now increasing to 100. So we want to use the z-interval command, and this is our confidence interval. So this means, with 95% confidence, we can say that the true population mean repair cost is between $2,566.70 and $2,733.30. Part D says, which confidence interval is the widest? So the first one, with a sample size of 40, has the largest range of values. So that is the widest. And this is because a smaller sample gives less information. Therefore, the interval needs to be wider to guarantee with 95% confidence that the mean is contained within it.